All right, this is lesson 3, 1.3. First of all, we want to start off with one more example of looking at the patterns, just so we can see a little bit better what was actually going on. So, some people actually might have seen this one the previous lesson, but for those who didn't. So we start off with one square, and then you can see there's that same one square. But on the next row up, you can see that there's two squares. And here you can see that's the same pattern, but we got three squares. So you can see we're building up, and on each subsequent layer, we have one more square than we had on the previous level. Now, some people said they actually saw it in terms of a diagonal, and then they kind of filled in the gaps. That works perfectly well as well. And some people said they noticed it went 3, 2, 1, 2, 1, etc. So figure 4 would go 4, 3, 2, 1 if you notice that. All those are great observations, and that will allow us to do this. So I'm going to highlight the whole picture and copy it because I know that that's going to be an important part. And then I just need to put 4 squares there. So I'm just going to copy 3 straight away because that'll make it easy. And then I'm going to put one more on here. So really, this was to practice for the quiz at the end of this section. So for picture 5, it will be the same, but we'll need 5 on the very last row. So I'm going to put 4, and then I'm just going to add one more square in here on the end, like so. And then we can go back and count squares if necessary. So I can see this picture has 1, 2, 3, 4, 5, 6. One thing we found helps students is if they put a physical dot on the picture. So you can actually use like a pen here, and then you can count as you put a dot. 1, 2, 3, 4, 5, 6. Because sometimes students would forget which dots they counted, perhaps count a dot twice. So that might be something to think about when you're doing these questions too. And then we can go back and fill in the answers. So I already remember the first few were 1, 3, and 6. Whoops. Hope if I typed 6 then. And then we talked about the next one being 10. And the last one, I don't know if I did count it or not, but there is 15 there. Now, rather than let Desmos do the work as we did previously, because last time we were focused more on the linear, non-linear side of things, this time we want to make sure, now we know that, can we remember how to graph this? So notice the thing that I've set up here already. So I got figure on the x-axis, and I got number of squares on the right axis, which matches up with this as well. This should be x, and this should be y. So as I'm plotting coordinates, figure 1 has 1 square, go across to 1 on the figure, and then this should be 1 dot here because this goes 1, 2, 3, 4, 5. So checking scale is important as well. 2 goes to 3, so 2 on the figure, and then go up 1, 2, 3. 3 goes to 6, so start at 3, there's 5, and then one more would be 6. 4 is 10. We can see that 10 is across here. And 5 would be 15. And you can see that this lines up with 15. Now, I did ask students, even before I plot this, can you tell if it's linear or non-linear? And I was looking to see if they could remember by looking at these numbers to see if there was a pattern. So this goes up by 2, then 3, then 4, then 5. As the number changes, that means that this is non-linear. If they all went up by exactly the same amount, then that would be a better indication this is linear. So it is curving. If you look particularly at the slope, say like here, and then here, you can really see that this slope here, I didn't do a great job of drawing a line there. Even if I draw a line in here, you can see that this one is far steeper than what this one is here. So we can see that the slope is indeed changing. And then what conclusion can you draw? At this stage, all we're looking for is it linear or is it non-linear? Because in the next unit, if it's linear, we're going to look at how you find the equation of a line. And that was all we did for our first part. It is important that you set up your Desmos account. If you're absent on this day, we will help you set that up. If you already have a Desmos account, just make sure you can remember your password. If you've forgotten what it is, you should just type it in your username, click forgot password, and it will send a reminder to your email account. It is important that it is your school email, though, otherwise it will be deleted because Desmos agrees not to collect data from any accounts that end in .edu. So we will skip through that part and we'll look exactly what's happening in lesson 1.3. So this is the SOL objective, but we're going to focus on our specific objective because this is a little easier to understand. We want to think of questions to investigate a subject and then identify the dependent, the independent variable needed to do this. And we talked about a little bit about dependent and independent last time, but really we're looking at the missing part of the data cycle that we did do last time, which is to ask a question. So we're going to do some quick little reminders and some new vocab. We did talk about bivariate data last time, where there's 2 parts to this. but we also want to make sure you're aware of univariate data, and that's things we want to stay away from, things that just have one data value, and that's not what we're looking at this level. Correlation, we talked about positive correlation. Oops, it'll be the other way around. Positive correlation going up to the left, and then from bottom left to top right. Negative correlation going from top left to bottom right, and also negative correlation last time as well. And there were those pictures that we talked about last lesson too. I also wanted to talk about correlation and causation. So that sometimes you see a pattern, but there's actually not a relationship. So the best example I could find for this was temperature and shark attacks. So as the temperature goes up, shark attacks go up. As the temperature drops, so do the shark attacks. And the question I ask students is why that happens. And most of them figured out that as it gets hotter, you go to the beach. If you're at the beach, you're more likely to go in the water. And if you go in the water, you're more likely to get attacked by a shark. Similarly, in the winter, you tend not to go to the beach. And if you're not in the water, you're not likely to get attacked by a shark. So that one explained itself pretty easy. This one here, temperature and ice cream sales. Obviously, once it's hotter, what are you more likely to buy? Ice cream. In the winter, when it's cold, what are you less likely to buy? Ice cream. So there's definitely those connections between those two. Now, if you plot the number of shark attacks and the number of ice creams together, you will find that there appears to be a correlation. Except clearly, buying an ice cream has nothing to do with whether you're going to get attacked by a shark. You're buying an ice cream mainly because it's hot, which is also the reason you're going into the water with the shark. So when we have that type of pattern there, we call it causation rather than correlation, and it's something just to watch out for, but not a major part of this unit. Independent and dependent variables. So the independent is the one that changes, and the dependent is the one that depends on the other variable. So often we'll have time as one of those going along the x-axis. That's a pretty common one. Sometimes we do have two of those. There are some IXL codes. If you log into Clever, search IXL, there are some codes here that you can actually try. And if you get a question right, your score goes up. If it goes wrong, it goes down. But there is a little explanation there as well. So you could certainly try either of these. As far as I can tell, they're all exactly the same. It's just that some later ones, these are more review. But this is when you would have first seen those in 7th and 8th grade. So the formulating questions. First one was UFOs or spaceships or flying objects or unidentified flying objects, I guess the correct name. Basically, supposedly the ships that aliens travel on if they're coming to visit Earth. So here was an example of a question that somebody asked. You're interested in when, where, why UFO sightings take place. You have to think of a question that you could investigate and then think about what two variables could you look at so you could make a scatter and see if there is indeed any correlation there. So one example is there a correlation between someone's visual acuity, their eyesight test score, and how many reports of UFO they've reported? So the independent one would be the eyesight, because that will obviously change. And then depending on the eyesight, that will depend on how many UFOs we're going to see or we think we're going to see. So that would be this one here. You just ask somebody, how many UFOs have you reported? So we did try and do predictions for this as well. Some people thought that if your eyesight was better, you would see more UFOs, basically because you can see further, and for that reason, you'd see more UFOs. Some people said the opposite, that if your eyesight's bad, you might see like a trash can lid being thrown perhaps across the sky, and you might think, oh, there's a flying saucer, when in reality, it wasn't. Which one's correct? We don't know. And until we collect that data and plot it, we're not going to know. But we're going to stop at that point. Today, it's thinking about what types of questions could we ask. Also, we had suggestions of location as well. So somebody asked, what's the correlation between the distance from a certain place and the UFOs reported? So notice we're only changing one thing here. We're changing the independent variable. We can still keep the dependent variable just fine. You can change both as well if you wish. And their thought was, perhaps if you live somewhere further north, it's going to be darker more. And for that reason, that's when you tend to see UFOs. It's nighttime. And if you live further south, it's going to be more daylight. Therefore, there's less UFOs that people might report. So that was certainly an idea that somebody had as well. And perhaps it's related to intelligence as well. Like perhaps you could do an IQ test. So perhaps people who have a higher IQ might recognize a weather balloon as a weather balloon, whereas somebody who doesn't know what that is might just assume it's a UFO. So that was an example that somebody could have as well. The second example we looked at was Target. If you're interested in why some people go to Target and others don't, one of the questions could be, is there a correlation between someone's emotional state and how often they go to Target? So notice also the word stems here if we're doing this as well. We're normally going to say, is there a correlation between one thing and then a second thing. So the thing with emotional state is you can't use happy, sad, kind of okay. We need something we can physically plot, so we've got to have a number. So this is why this quest part here is really important. Thinking about how you can ask the question. So you ask them, what's their average daily happiness score, 1 to 10? I think you'd have to be clear, 10's the happiest, 1 is the saddest, etc., etc. And then the dependent variable, how often do you go to target? So people's emotions change, that's the independent. How often they go to target will depend on what their emotions are. And we asked for predictions on this as well. Some people said that if they were happier, they think they would go more to target. And their logic being that if you're sad, you might be like, I don't want to go out today. Like, I just want to stay at home. And other people said the exact opposite. They've had a really bad day. For that reason, they might want to go shopping. How do we know which is the correct one? We would have to collect some data. So this unit really is looking at how do we find answers to questions that we don't know the answer to. If we can collect some data, plot it, we might be able to find that out. We then tried to split people into groups, and we got different people to think of ideas. We've rearranged this. This is situation 6. We picked this one because this is the one that people found easier to do. And I'll show you the other ones, and you can have a practice if you weren't in class thinking about what questions could you ask. TikTok was popular because students know TikTok, they know social media, and they had some really good ideas for this. Also talking about TV shows. Why people make more money than other people, why certain shoes are popular, shopping once again popular. Interested in why some dogs get adopted quickly or slowly. People tended to find that one a little bit more difficult, and that's why this is near the end. We got to do 2 or 3 of these, and then the lesson ran out of time. And the aim was never really to do all of the scenarios, but it was just to start brainstorming within our groups some of those possible ideas. So really for this lesson, it was really just the idea of creating a question, thinking about what you would ask and then how you can collect that data. And then in the following lesson, it's going to put all those sections together. And so you can actually go through every single step on the data cycle. And that was the end for this lesson. It really, like I said, it was thinking about a subject, identifying the independent variable, the dependent variable, and thinking of a good question where you could collect data.